Hello, welcome everyone, welcome back to my channel. Today in SAT we are doing Heart of Algebra, and in that we are gonna start with linear inequality. Well, we have completed linear equations, how to solve them, and simultaneous equations, that is linear equations in two variables. We have seen that as well. Today we are doing linear inequalities. So let me start. An inequality is an expression where you will see the sign of inequality. That means if I'll write x plus 1 less than 1, it means this whole expression is less than 1. So in place of equals to sign, you will see inequality sign in this case. Now, while solving a linear equation, you will get a 1 and a fixed value of x, whereas here you will get a whole range of values. Solving inequality is exactly the same how we solve any linear equation. Only difference here is instead of equals to sign, here you will find the inequality signs. Well, definitely you all are aware of these inequality sign. That means less than, this represents a less than, so 2 less than 3, so that open side is towards the bigger number, whereas that weak side is towards the smaller number. Or this would be 2 greater than 1, 2 less than equals. Well, it's less than equals means whatever the value here, that value can be greater than or it can be equals to 2. Similarly, greater than equals means that number is greater than as well as it can be equals to the number on the other side. As I told you, the solving part is exactly like how we solved a linear equation. So I'm starting with linear inequality solution. Take a very simple example, x plus 1 greater than 2, and simultaneously I'll be showing it on a graph so that you can understand the interpretation of it. So x plus 1 greater than 2. When I'll solve this one, how we solve equation? By subtracting 1 to both the sides by isolating x. Similarly, here we also are isolating x. So subtracting 1 to both sides, or I can say transposing 1 to right hand side. Change the sign, it will be x greater than 2 minus 1, x greater than 1. You can clearly see it was just exactly how you solve any equation. When I represent it on a number line, because it's all about representing it on x-axis. Say for example, this is 0, 1, 2, 3, minus 1, minus 2, minus 3. When I represent this inequality, that means x is greater than 1. So all the values of x that are greater than 1 will be considered. So till infinite. So as I told you, in inequality you will get a range of values. So you can clearly see we got a range of values that x can take all those values that are greater than 1. But it's not equals to 1. There is no equals to sign here. That means x can be any value greater than 1 but 1. It cannot be 1. And that's why when we are not including that particular value, we make a hollow circle. So it's unfilled circle. Unfilled circle is drawn when we exclude that particular number. Now, if instead of x greater than 1, if it would be x greater than equals to 1, then in that case, we can show it like this. Same, it's 0, 1, 2, 3, 4. -1, -2, -3. So when we are drawing x greater than equals to 1, that means at 1, I'll draw a circle, but this time this circle will be a filled circle. This filled circle represents that we are including 1 because it's equals to 1. That means we have to include 1 as well. So we can clearly see that whole range, it can take up any value of x plus it can take 1 as well. So a filled circle represents that the value is included. Now similarly, suppose in place of greater than, if it would be lesser than 1, that means if it's x less than 1, then it's exactly the same. The only difference here is your arrow will be towards left side, because we have to find this signifies that x can take up any value lesser than 1. So lesser than 1 are all the values that are on the left side of 1. So let me represent it on x-axis. It would look like this. I'll do same. 0, 1, 2, 3, -1, -2, -3, -4. So I'll draw a circle, and definitely it will be an unfilled circle, obviously, because we are excluding 1. And x is all values that are lesser than 1. So it will go towards this side because it includes all the values lesser than 1. It goes till negative infinite. Similarly, if it would be x less than equals to, x less than equals to 1, in that case we will be doing same exactly. Our arrow will be towards left side. The only difference would be here is we have to draw a filled circle. In previous one it was unfilled because we were excluding the value, but here we have to include the value as well. So the circle is going to be a filled circle. So it would be to this side. And this is how you can represent any inequality on the graph or on the number line. Let me see some question how we can solve them. Well, if you know how to solve equations, it's very easy to solve any linear inequality. Now, it's exactly, since it's a fraction, I need to isolate x. I will multiply 2 to both the sides. That will be my first step. Multiplying 2 to both the sides, it will be 2x minus 1 greater than equals to 2, because I have multiplied 2 to both the sides. The next step would be adding 1 to both the sides, or you can say transposing. So this will give you 2x greater than equals 3. And finally, dividing both the sides by 2, you'll get x is greater than equals to 3 over 2. That means x can take up all the values of x that are equals to and greater than 1.5 or 3 over 2. And it's very easy. You can represent it on a number line. Let me do it quickly. So it would be like 0, 1, 2, 3, -1, -2, -3, and this will be 1.5 would be here. So drawing, this will be a circle and this will be a filled circle as we are including 1.5, and all the values are greater than 1.5. So this is going to be range. Let me solve one more question. Now here it's a fractional one. So first we have to solve the fraction which is on the left hand side. Clearly 2 and 3 are the denominators and we have to make the denominators same by finding their LCM. LCM of 2 and 3 is 6. So I need to make the denominator 6. I'm writing the question as it is here, which is x plus 1 over 2 plus x over 3 less than equals x plus 3. So in order to make the LCM same, I have to multiply it with 3 and similarly multiplying it with 3. Multiplying it with 2 and similarly multiplying it with 2. I'm not touching the right hand side. There is no sense of doing it as of now. Now this will be 3 times x plus 1 over 6 plus 2x over 6 less than equals x plus 3. Or since we have made the LCM like the denominator same, I can combine the numerator, which is on expanding I'll get 3x plus 3 plus 2x less than equals x plus 3. If you find it difficult, I would suggest to go back and see how to solve linear equations. If you have done the mastery over it, linear inequalities are very simple to solve. This is 5x plus 3 over 6 less than equals x plus 3. Now, we can multiply 6 to both the sides. Once we have a common denominator on one side, we can multiply that number to both the sides. So, multiplying 6 to both the sides, I'll get 5x plus 3 less than equals 6 times x plus 3. Expanding, I'll get 5x plus 3 less than equals 6x plus 18. Let me bring it here. So 3 minus 18 less than equals 6x minus 5x. Minus 15 less than equals x, or I can say x is greater than equals negative 15. There is an important note. When you multiply a negative number to both the sides, or when you divide a negative number to both the sides, inequality always changes. That means, suppose if it's minus x greater than equals 15. So if I am multiplying negative 1 to both the sides, it will become x less than equals negative 15. So the important note is, whenever you are multiplying both the sides by negative number or you are dividing both the sides by negative number, the inequality always changes. So it's very important note. Moving on to one of the most important type of inequality, which is called a combination of inequality. The previous questions were having the single inequality, but what if we have two inequalities? How to solve it? See this question. See this one. Our main aim is always to isolate x. So in previous question, we have seen that whatever you are doing on left hand side, you have to do it on right hand side. Similarly here, whatever you are doing on one side, you have to do it all on the three parts. You have to do it. So in order to isolate x, I need to multiply this with 2. So if I'm multiplying this with 2, I have to multiply every number or every side that you can see with 2. That means if I'm multiplying this with 2, I have to multiply this with 2. I have to multiply this with 2 as well. 6 less than equals x plus 1 less than equals 8. Now to isolate x, plus 1 is remaining, so I need to subtract 1 from all the sides. So subtracting 1 and subtracting 1. So final answer is 5x 7. That means x is greater than equals 5 but is lesser than equals 7. And when I represent this inequality on number line, you will find a range, a specific range, a range which is not stretching infinitely, but instead it's lying in mid like this. It's 0, 1, 2, 3, 4, 5, 6, 7, -1, -2. So x is lying between 5 and 7 and including 5 and 7 both. So at 5 I'll draw a circle, filled one, and at 7 I'll draw a circle, a filled one, and a line connecting them. It represents that because from where it's starting, that represents the circle. In previous one it was stretching infinitely. That's why we were representing the other end with arrow, because other end was open end. It was an infinite value which we cannot there is no end of it. But here the value of x is lying between 5 and 7, and that's why the circles are over 5 and 7, representing that the range is starting from 5 but ending at 7. This is how you can represent the combined range where you have both the end values given. And this is how you can solve the two inequalities or combined inequalities. Well, this was a very basic introduction of linear inequality, and in the next video we will be doing the questions, the harder questions, and also about the introduction of the modulus. So that we will be doing in our next class. Well, I am providing one-on-one personalized classes, group classes for both SAT Maths and SAT English, and classes are at just $7 per hour. So if you want the demo, all you need to do is just email us at exactacademy@gmail.com. And if you want to purchase the mock papers, for that also you can email us at exactacademy@gmail.com. For the free worksheets and material, you can access it on our website, which is xiacademy.com. So that's it for today. Thank you. Have a great day.